Today, a flight across the Atlantic takes about 8 hours, but in the late 1990s, passengers were completing that same journey in under 3.5. It is rare for a major technological advancement to simply vanish from daily life, yet that is exactly what happened to commercial supersonic flight. Following the Second World War, the United States and the Soviet Union controlled much of the aviation industry. To compete, European nations looked past the next generation of subsonic flight and aimed for a significantly more complex objective. In 1962, the governments of Britain and France signed a formal treaty, committing to a joint partnership to build a supersonic passenger jet. This partnership, fueled by national pride, set the stage for an aircraft that would test the limits of both engineering and government finance. This project became the namesake for a concept in behavioral economics known as the sunk cost fallacy, or the Concorde fallacy. This chart compares the initial budget against actual spending. Projected at £150 million, costs climbed past £1 billion. Despite signs it would be unprofitable, both governments increased funding, determining they'd already spent too much to abandon the project. The result was a mass transit vehicle that required the maintenance budget and fuel consumption of a high-performance race car. This political commitment to a spent investment resulted in an aircraft that existed outside the standard rules of commercial aviation. Because no existing airframe could survive the friction of sustained supersonic travel, the Concorde required a massive specialized manufacturing effort. Engineers developed specific solutions: the delta wing, 4 powerful engines, and a movable nose that allowed pilots to see the runway. These systems allowed the aircraft to cruise at 60,000 feet, reaching speeds of Mach 2, roughly 1,300 miles per hour. Technologically, the engineering teams successfully built a commercial airliner that met every performance target established in the initial treaty. However, that technical success was met with a series of restrictive environmental and market realities. This diagram illustrates the aircraft's primary and secondary sonic boom carpets. Concorde generated a continuous noise profile that reached the ground across a wide area. The disruption was significant enough that governments banned overland supersonic flights, restricting it to transoceanic routes. The aircraft consumed fuel at 16 passenger miles per gallon. This high dependency on petroleum became a liability during the 1973 oil crisis. With a narrow cabin and high operating costs, airlines charged roughly $6,000 for a single seat just to cover their expenses. The combination of noise restrictions and fuel costs confined the aircraft to a single transatlantic corridor, serving only those who could afford the premium price of speed. The aircraft operated as a niche service until July 25, 2000, when Air France Flight 4590 attempted to depart from Paris. Runway debris caused a catastrophic fuel tank rupture during takeoff. The resulting crash claimed 113 lives. While the airframe had maintained a high safety record for decades, this catastrophe changed public perception and increased the difficulty of operating the aging fleet. In the years following the crash, the fleet required expensive safety modifications. These costs arrived alongside a significant downturn in the global aviation market following the attacks of September 11th. When Airbus withdrew its maintenance support, British Airways and Air France were forced to permanently retire the fleet in 2003. Despite its retirement, the project left behind an organizational legacy. Developing the aircraft required a level of cooperation between the British and French aerospace industries that had not existed before. This table compares the governing bodies of the Concorde project and Airbus. The institutional framework and shared expertise established during the 1960s provided the direct blueprint for the formation of the Airbus consortium. By learning to build the Concorde together, these industries established a collaborative model that eventually ended the American monopoly on commercial aviation. Modern companies are now attempting to revive supersonic travel by addressing the specific economic and physical limitations that stopped the Concorde. Boom Supersonic's Overture aircraft is designed for Mach 1.7. This intentional trade-off increases fuel efficiency and reduces the impact of the sonic boom. NASA's X-59 is testing specialized airframe shapes designed to create a quiet supersonic profile, aiming to provide data that could overturn current overland flight bans. The Concorde proved that human engineering can conquer the speed of sound. The next generation of commercial flight will depend on whether that incredible speed can be balanced with sustainable economics.